The illusion that bends reality. Something impossible just happened. Physicists just captured an illusion so rare, it doesn't just bend light. It bends our sense of reality itself. A solid cube, completely motionless, appeared to twist and rotate as if space itself were melting. And here's the mind-bender. It all happened without breaking Einstein's laws of physics. This isn't CGI. It's not a trick of the eye. It's a real glimpse of what the universe looks like when you push the limits of light, time, and perception. It's called the Terrell-Penrose illusion, a phenomenon predicted more than 60 years ago, and for the first time, we've finally seen it. 1. The race beyond sight. For over a century, Einstein's theory of special relativity has defined how we understand speed, time, and light. It tells us that nothing, absolutely nothing, can move faster than light. But as something approaches that cosmic limit, weird things start to happen. Time slows down. Distances shrink. Even light behaves differently. One of those predictions is known as Lorentz contraction, the idea that an object moving near light speed should physically appear squashed along its direction of motion. The math says it's real, but no human eye, no camera, had ever witnessed what that actually looks like. Back in 1959, two brilliant physicists, Roger Penrose and James Terrell, asked a deceptively simple question. What would you really see if something flew past you at near light speed? They realized something everyone else had missed. Light from the back of an object takes longer to reach your eyes than light from the front. So the image you see isn't instantaneous. It's a mix of moments from slightly different times. And when that happens at relativistic speeds, something strange occurs. The object doesn't look squashed. It looks rotated. That's the Terrell-Penrose illusion, a visual distortion born not from imagination, but from the geometry of spacetime itself. For decades, it lived only in equations and simulations, a ghost in Einstein's math. We could describe it, but we'd never see it. Until now, 2. Recreating the impossible. In a quiet laboratory in Vienna, a team of physicists decided to make the impossible visible. No particle accelerator, no spaceflight, just a cube, a sphere, a laser, and one of the fastest cameras on Earth. Their secret weapon? Ultra-fast laser pulses, each lasting only 300 picoseconds, a tenth of a billionth of a second. Each pulse bounced off the cube, and the camera, synced with microscopic precision, opened its shutter for that instant only. What it captured wasn't the cube itself, but a slice of light. Then, they nudged the cube forward, about 1.9 inches, and fired again. They repeated this hundreds of times, stitching each frame together like cosmic film. And then it appeared, a cube that looked like it was racing through space-time, twisting, stretching, and bending light around it. In reality, it never moved at all. It was an illusion, but not a fake. A faithful recreation of what your eyes would actually see if you stood beside an object moving at 99.9% the speed of light. When they repeated the experiment with a sphere, moving at 2.4 inches per step, the illusion became even stranger. The sphere seemed to curve and reveal its hidden far side, as though geometry itself was folding. Reality looked like it was glitching, yet every pixel obeyed Einstein's rules. 3. The geometry of light and time. So what's really happening inside that illusion? Why does a stationary cube look alive, twisting through space-time? It's all about light travel time. When something moves incredibly fast, light from its rear has to travel farther to reach your eyes than light from its front. That tiny delay, just billionths of a second, scrambles how your brain assembles the scene. Instead of seeing the true shape, you see a rotated version of it. Your perception warps reality because light arrives out of sync. That's the Terrell-Penrose illusion in action. It doesn't violate relativity, it confirms it. Einstein predicted that moving objects physically contract. Penrose and Terrell revealed how our eyes would perceive that contraction as a twisted, shifting mirage of motion and geometry. As lead researcher Dominic Hornoff explained, with the right idea, you can recreate relativistic effects in a small lab. It shows that even century-old predictions can come to life in a really intuitive way. Think about that. We didn't need to chase light across the galaxy. We just needed to understand its geometry. A simple cube became a mirror reflecting the deepest rules of the universe. For a moment, we didn't just test relativity, we saw it. For beyond the experiment. This experiment isn't just a neat physics demo. It's a bridge between theory and perception. It shows how even our most trusted senses can deceive us when confronted with the universe's limits. What's amazing is that this illusion, born from light-speed motion, echoes a larger truth. Reality itself depends on your frame of reference. Move fast enough, and space, time, even shape, all shift around you. That's why the Terrell Penrose illusion matters far beyond this lab in Vienna. It teaches us that what we see isn't always what is. Every photon carries a timestamp, and together they paint a distorted but truthful image of space-time. And maybe, just maybe, this small experiment gives us a glimpse of what interstellar travelers would see if they ever reached near light speed. The universe bending, morphing, and revealing hidden angles that only light itself can show. What these scientists captured wasn't just a clever visual trick. It was a window, showing how reality warps when speed bends time. The Terrell Penrose illusion proves that light doesn't just reveal the universe. Sometimes, it plays with it. So next time you think of the speed of light, remember, what you see might not be what's real. And that's the true beauty of physics. It reminds us that even the simplest cube can hold the secrets of space-time itself. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe, and tell us what you think this illusion says about the universe we live in. Your support means the world, and it keeps our journey going.